Hello, welcome to another video from Aeology. So nowadays we are using language model every day in our life, and people are using GPT-4, ChatGPT, and other language model like Llama, stuff like that for their day-to-day task or maybe for their own project. But this is important to know that different people can gain uh, different level of information and get different level of accuracy in terms of how they are interact with the language model. So today I'm picking two papers about chain of thought, and I want to talk about chain of thought prompting and how this is important and how this would be maybe the future way of interacting to the language models. So the first paper we want to talk about is, let's start with this second one, with the multimodal chain of thought reasoning in language model. So this paper is published in 17 February 2023, and the theme under that is the Amazon science. Basically, I can explain that this way. So we have, let me zoom in a little bit more. So we have a question like which property do these two objects have in common? And we pass an image. One of them is a cracker, one of them is fries, and we are saying uh, a context, we are passing a context. So select the better answer. The common property between two is both are soft or salty. And in the output, instead of just saying, oh, salty would be the answer, um, there is a rationale. And then from the rationale, we reach to the answer. So we call this rationale a chain of thought. So look at these, for example, it said, look at each object. For each object, decide if it has that property. Potato chips have a salty taste. So first of all, we detect this as a potato chips. Both objects are salty. A soft object changes shape when you squeeze it. So uh, we have another understanding here coming from the question. Like, should be soft as another answer to this question. The fries are soft, but cracker is not. The property that both objects have in common is salty. So this is the rationality behind that why we choose this answer. Language model are not really reasoning, but uh, the thing I want to talk about here in this paper is that uh, if we have trained the language model to learn the rationale, then from the rationale go to the answer. So that would give us a better result. And in terms of accuracy, it can even increase about 16%. So let's see the abstract. So it said large language model have shown impressive performance on complex reasoning by leveraging chain of thought prompting to generate intermediate reasoning chain as the rationale to infer the answer. This is whatever we have discussed so far. However, existing chain of thought study have focused on focused on the language modality. So uh, I will talk about another paper that this paper, chain of thought prompting elicits reasoning in large language model after this. They mention here many papers talked about just using the language model, but here they are adding also another part, make it multimodal, so we are passing an image. So they said we propose multimodal chain of thought that incorporates language and vision modalities into two-stage framework that separates rational generation and answer inference. In this way, answer inference can leverage better generated rationalities that are based on multimodal information. With multimodal chain of thought, our model under 1 billion parameters outperform the previous state-of-the-art GPT 3.5 by 16%, from 75 to 91% accuracy, and even surpass human performance on science question answering benchmark. And code is publicly available. This is really cool to get high performance. Not only that, but look at this. It is just under 1 billion parameters. So it is something that many people can uh, train using the current infrastructure they have. It doesn't need to be very big machine to generate a trillion parameter like GPT-4. So one way To solve this problem, let me explain that in this way. So one way to solve this is that, so we have an image and we have some models that they can generate image captioning. And image captioning actually give us a text. Yeah. So image captioning model, I can call them. And from here, we will get a text describing that image. Then we also have a prompt, let us say a text prompt. And now we have text describing image, and we have the text prompt. It's coming from the user. And now we can pass them to a model and ask them to generate a rational for us. So that is like our language model. And then from a rational, we can say, give us an answer. So I can say this part is chain of thought, and this part is the answer. So in one of the experiments, they've done this. So they have an image, and then just to have the same domain of information, they convert this image to the text describing that image and use that. But they found that it is not being useful in terms of accuracy, it's not giving them a very good performance. And also, look at this, that they were using that multimodal, using the T5 model. T5 model is already available from Hugging Face, and it is encoder-decoder model. So they mention here that if they use that caption to generate rationality, just rationality, that performance is not that bad. But if they want to just use that captioning and predict answer, the performance is not good. That's why they said, so instead of doing that, maybe we can get some feature like DETR, and they fuse the vision feature with encoded language representation before feeding to the decoder. So in encoder part of the, so here in encoding part of the T5, they have the feature fused from DETR. So this is the first version to do the captioning. So another version they've done is, so instead of having this, we have DETR. So we get like embedding, and we pass that embedding, that text prompt go to the encoder of the language model. So I should, so this part maybe I need better details here. So that would be T5 model, encoder, decoder, both are, because are same, are text, that would be okay. But now because we want to do it a little differently, that would be like, let me also change this to T5, 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 and here now we have one embedding and we have a text prompt, and text prompt need to go to the T5 encoder. So we need small piece here, T5 encoder, and this will give us some embedding of the text. Then we pass these two, or I can say this way. So we pass these two to the only T5 decoder part. Okay, so they also use like clip. I think the clip is used for those image captioning, converting that image to text. Then the DETR also resonate. Uh, so they said they fuse vision features with the encoded language representation before feeding to the decoder. So as we explained here, so they get the embedding by the DETR, some of the step of the segmentation using transformer, and then get this embedding, fuse them, maybe getting average or doing some other stuff on it, and then pass that to the decoder of the model to generate chain of thought, then generate the answer. And there is a point also here, I want to talk about this too. So yeah, this is the point. So they said uh, when we want to predict the rational, so that's the step we have figured out so far is okay. But when we want to generate the answer, we also again pass this as another feature, like a residual network. So we don't want to just get a rational and get the uh, answer. We again have all of these embedding, and uh, we have all of these as like a new embedding. We have these features so far. So we get this feature, we get this feature from this, we get this feature from this. We just fuse them, maybe just by adding them together, and then we will fine tune the answer inference to get the answer. So it doesn't need to be like different model, just one model, T5 model can do both. And that depends on the prompting that we want to fine tune on it. So that's the whole thing that we are doing that. And they are showing here that if we do not generate this prompt, what happens if we do not use the vision feature, just use the captioning, what will happen? And they find out, let's see some of the result. As I mentioned, if we just want to predict the answer and use just captioning, performance is low. But if you just want to use rational just by captioning, it's not that bad. But if we use vision feature, both of these rational generation and the answer generation improved a lot. So we have the question, the context, options, yeah. And yeah, so if it's back here, so if we pass question, context, and those uh, marks, and we want to predict just the rationality using a vision feature, the performance drastically improve. And the main reason is that maybe the captioning is not capturing most of the information need required for answering that question. But vision feature embedding that will give us a better space of search for the model to find the better connection in the neurons to get the answer. And that is fair enough. And another part also they showed here is that, yeah, so if we first generate rationality and then generate answer, if we just generate the answer, and if we generate answer and then rationality, what will happen? They mentioned we observe all 12.54% accuracy decrease if the model predict rationalities before answer. So if they just predict rationality before answer, the accuracy is calculated based on the final answer. So they're mentioning if we just do this, so we say predict rationality, then say us answer. So this is different than the chain of thought that we say. So we say generate rationality, at the end, give us the answer. You know? So we are not adding rationality here compared to what we had here, like this one. So this is different than that. So one of the naive way is to say, so the answer of the prompt should have rationality, and from the rationality, we have the answer. So if I want to explain it better, maybe I can say from here. So I can say this is the input, and that is the whole output you want to give us. If we want to do this, there are some problem here because the language model doesn't know exactly, it's really doesn't do the reasoning because it can even do some mistake with those rationals. And maybe the answer is not relevant to the rationality if we just want to generate them just together. But if we first generate rationality, then use this rationality as another input to the model, then ask it to answer that, that would drastically improve the performance. That's the point. So here they are mentioning that if they just want to generate rationality and then answer and do not use the rationality for getting the answer, it's decreasing the performance even. But if we, and the other way, if we say generate answer then rationality, it is a little better, but still it is lower than when we just say give us the answer. So it is not a good way to train a model, a language model, and just add more details to the output during fine tuning, just to give us by just assuming that this will help the model to get the better answer. But the way that they have proposed here is we have the rationality, Then we combine it with the uh, questions and all of the input features that we have, fuse them, and again ask for the inference. And yeah, that's the whole point of this paper. If you see this formulation, that would be really easy to grasp it and understand it. Also, there are some pseudocode here. They are really easy to understand. And the way that they are fusing, it's explained here. The linear, very similar to what we have, for example, in the mix-up paper. And yeah, that's it. This is really cool. And there is a code, you can go and play with it. And also they are mentioning here, for example, let's see this. There were 5 solute particle on left side of the membrane and 4 solute particle on right side of the membrane. And the rationality is not right because we don't have any 5 particle in the left. So this rationality is not right. And based on that, I think the answer was wrong. So that's one of the reasons we cannot always say that the language model is exactly reasoning, because sometimes there is mismatch between the rationality they make and the final answer they give us. And also another good point that we understand is that it's not good to ask the model to predict the rationality while predicting the answer. It's good to use those rationality generated for predicting the answer. The second paper is very similar. So this paper is published in 10 January 2023. And look at these times. It is not like the paper they just started. They uh, train lots of model on top of that. So even before getting to this point that we have ChatGPT, this kind of prompting was under practice by some big companies like Google and Amazon. So it's cool to look at what we'll have in the future. So in this paper, they said we explore how generating a chain of thought, a series of intermediate reasoning, significantly improved the ability of large language model to perform complex reasoning. In particular, we show how such reasoning ability emerged naturally in sufficiently large language model via a sample method called chain of thought prompting, where a few chain of thought demonstrations are provided as exemplar in prompting. Experiment on 3 large language models show that chain of thought prompting improve performance on a range arithmetic, common sense, and symbolic reasoning task. The empirical gain can be striking. For instance, prompting a Palm 540 billion parameters with just 8 chain of thought exemplar achieve a state-of-the-art accuracy on one of the benchmark of math and math word problems, surpassing even fine-tuned GPT-3 with a verifier. So all of these papers are showing that the chain of thought is really, really important. So this is one of the standard prompting that we can do. You can even try it with GPT-4 3.5. And this is a chain of thought prompting. So we can say the question, and in the answer, we fine-tune that model with some level of details. So in the previous paper, we showed that this sometimes even can decrease, but that was multimodal. But here they are showing for some of the cases, like for arithmetic and common sense and symbolic reasoning, it is getting better performance. So what if they have trained this in a way like that multimodal, in terms of they generate rationality, they again pass that with all of those features to the model. So I think one of these problems that this paper is solving is that autoregressive way. Jan Lipun also mentioned in one of his tweets that having this autoregressive means that after the sentence is getting longer, language model doesn't know exactly what's going on, because the autoregressive way of uh, generating tokens is not way that the people do when they are talking. Uh, there should be like a thinking beside, like a residual network to connect all of this information when we want to get some final answer. That's why we say that when we generate all of these together, we are losing some of the information and some of the context, even though like the range of the token the model can get is higher, for example, for GPT-4. but that's one of the problem I think need to be solved in the future. The way they did it is just they have prepared some data and fine-tuned the model on top of that. And by fine-tuning, it's like fine-tuning the whole model, not just the last layer or just using the zero-shot approach. And they are showing that in some of the models like Palm, it's showing that in the billion parameters, about half trillion parameters, the performance is really getting higher and higher. They are showing here, so we can have a standard prompting and we get very low performance. We can just ask them with some equation. For example, we say, this is the question, this is the equation. And maybe we can also ask, these are the variable. Or we can say, do the reasoning after the answer, like the answer is this, and reasoning is like this. And chain of thought prompting is as what we discussed. And another important thing is that they showed that increasing the size of the model is fixing some of the errors that happening in rationality. And of course, the chain of thought is this kind of prompting is happening in the large language models. If you train like here 62 billion parameters, uh, we have most of the case in this example, we have an error. But just by increasing the size, rationality get better. So maybe this is related to the data pruning or because like we have seen here, they could train a very good model with those way of treating to the rationality and answer just by a T5, less than a billion parameter. Yeah, and for example, let's say this. So some of the prompt for coin flip said a coin is heads up, Ka flips the coin, Sherry flips the coin. Is the coin still heads up? So look at this chain of thought. It said the coin was flipped by Ka and Sherry, so the coin was flipped 2 times. So far it's right, which is an even number. The coin started heads up, so after even number of flips, it will still heads up. So the answer is yes. This is very clean rationality. And the cool part, I just want to compare these two papers to get this. Here they show that if we generate rationality before answer, it decreased the performance. But maybe this is just something happened for multimodal. And maybe the way that they fine-tune the model is different. Or maybe Palm is better. Uh, so I don't know anything about the underneath of this, but just comparing two paper, look at their uh, results and the way that they are interpreting the result and two different approach. But both are working on the chain of thoughts. That's it. I hope you enjoyed the video. Please leave a comment, subscribe, and share with your friends. Have fun.